Hey guys, this is Professor Janacek. I want to go over a couple more examples of integration by parts. Let's start with the integral of x sine x dx. Now I'm going to be using this kind of Lipit technique to help me choose u. Remember, this doesn't necessarily guarantee the best u, doesn't necessarily guarantee it's going to always work perfectly, but it's a good place to start. I don't have a logarithmic function, I don't have an inverse function, but I do have a polynomial function, and that's what I'm going to let u equal. So we'll let u equal x, and that leaves everything else, sine x dx, for dv. If that's the case, then du is dx, and v would be the integral of dv, which is the integral of sine x dx, which is, remember, we're integrating sine, so we get negative cosine x. Of course, plus c would be what we typically write out, but I'm going to leave that arbitrary constant till the end. I'm going to collect it all in my final answer. So here we have the integral of u dv. Again, this part is u, everything else is dv. According to my formula, that's going to be u times v minus the integral of v du. So we're going to take u times v minus the integral of v du. So that gives us x times negative cosine x minus the integral of negative cosine x dx. Just filling in those blanks. Now we can simplify this just a bit. This is negative x cosine x. Use the commutative property there. Minus a negative, factor out that negative inside the integral, gives me a plus times the integral of cosine x dx. Now all we have to do is integrate there at the end. The integral of cosine x, remember we're integrating, not differentiating. The integral of cosine x is positive sine x. Of course, this is the last of the integration. This is an indefinite integral, so that means I have that arbitrary constant there at the end, plus c. And there we go. Not so bad. Let's take a look at the next one. It's the definite integral. We're going to integrate from 1 to 2 of the natural log of x dx. This is a really nice one. I'm going to start by letting u equal to the natural log of x, and the dv portion will simply be dx. If that's the case, then du is 1 over x dx, and v is the integral of dv, which is the integral of dx, which is just x. Again, not going to write that plus c there. I'll hold all those constants till the end. So we are looking at integrating u dv. Again, this is u, this is dv. That's going to give us u times v minus the integral of v du. So we're going to have u times v minus the integral of v du. So that gives us the natural log of x times x minus the integral, still keep that definite integral from 1 to 2, of v, which is x, times du, which is 1 over x dx. Ooh, we can simplify quite a few things here. I'm going to go ahead so there's no confusion about what the argument of the natural log is. I'm going to move that x to the front, so I have x natural log of x minus the integral from 1 to 2 of 1 over x times x. Ooh, that just gives me a 1 dx. That's going to be easy to integrate. That gives us x natural log of x. You'll notice I am holding off and evaluating this integral, this definite integral, until the very end when I've got it all figured out. I guess technically I should have put that there so that we knew, oh, we still have to evaluate that from 1 to 2. And now at the end, if I'm integrating dx, we simply get x We're going to evaluate this whole thing from 1 to 2. Before I do that, I do want to point out, you'll notice that when we integrated the natural log of x dx, we end up with x natural log of x minus x. Of course, if this is an indefinite integral, we'll have the plus c. So that's a nice little thing to remember. That's often given as a formula for integrating the natural log of x dx. Kind of nice. Let's go ahead though and evaluate this at our limits of integration. We get 2 natural log of 2 minus 1, which I don't need to write coefficient of 1, times the natural log of 1 minus 1. One little step at a time so we don't lose anything. I'm going to distribute that negative, so that gives us plus 1 in the back. Next thing, I notice the natural log of 1 is 0. We can also combine the negative 2 and the positive 1. That gives us 2 natural log of 2 minus 1. And there you go. Not so bad. Enjoy.